We have the Jacobian, and now we're ready to use it to be able to integrate in spherical. Here's an example. Evaluate this triple integral over x squared, where the three-dimensional shape that we're integrating over E, the solid, that is bounded by these two hemispheres. We have a hemisphere with the radius of 3 and a hemisphere with the radius of 4. And then also the other bound is the xz plane. So we have to figure out what the setup is going to be for the spherical coordinates. If we work at this equation, square both sides, we'll have x squared plus y squared plus z squared is 9, and that's rho squared is 9, or this is the equation of the sphere, rho is 3. Now this guy is going to be equation of the sphere, rho is 4. So rho will go between 3 and 4. Now, we got to convert this guy x squared. It can't stay as x. Everything's now rhos, thetas, and phi's, and so if you know that x is rho sine phi cosine theta, we have to square everything. So that's going to be the integrand, x squared, which is now going to be replaced with rho squared sine squared phi cosine squared theta. Well, what about the bounds on phi? Remember, when phi is on the positive z-axis, it's 0. And when phi is on the xy plane, it's pi over 2. We're going past that, down to the negative z-axis, which is phi being equal to pi. So phi is going to go all the way through 0 to pi. If we don't let phi go past pi, we end up getting what we need. If we had to do that, we get what we need by swinging theta from 0 to 2 pi. Here we don't need to swing theta from 0 to 2 pi. Here theta is only going to go from 0 to pi as well. We don't have the other part there of the other side of the x z plane where the y's are negative. So we throw these in, and remember that dv becomes not just d rho d theta d phi, it becomes rho squared sine phi d rho d theta d phi. This integrand was x squared, and the rho is going from 3 to 4. The phi is going from 0 to pi. The theta is going from 0 to pi. I have it listed as theta second and phi last, but those can be interchanged. And so we have it. And we are ready to integrate. We just have to put terms together. We have a rho squared, another rho squared. We have a rho fourth. Sine squared phi, another sine phi. We have sine cubed phi. And then we have a cosine squared theta. That's separable. We have the ability to be able to write it as the product of 3 separate single variable functions, and the bounds are all numerical. We can take advantage of that and do 3 separate integrals. Okay. First integral. Sine cubed on phi. You take one of the powers of sine off, you'll be left with 2 of them still. Convert those into cosine and do a u sub. So we take one of the powers of sine off, left with sine squared, convert those into cosine squared by the sine squared plus cosine squared is 1. And then we can do a u substitution by letting u be cosine theta, phi, sorry. Because then the derivative is minus sine phi d phi. And so all of this is du, but times negative 1. So negative du is going to take the place of all of this. This guy is just going to become 1 minus u squared. We can flip it and call it u squared minus 1. And it's going to be u cubed over 3 minus u. So cosine cubed of phi over 3 minus the cosine of phi. Evaluate from 0 to pi. We put a pi in. And then we put a 0 in. The cosine of pi is negative 1. We cube it, we get negative 1/3. And then we get a negative 1 minus a negative 1. So we add 1. And then we put a 0 in. These guys will be 1s. We have a third minus 1. Upper limit minus lower limit. 2/3. And then negative 2/3. Or we can put the 1s together and then put the thirds together. Either way, we end up with 4/3. That's 1/3 of the answer. The other part is going to come from integrating the theta and then the rho integral. When you have cosine squared in an integral, you have to go with the half angle or double angle formula. So we trade it in for 1/2, 1 plus the cosine of twice theta. And then we can integrate these parts. That's just going to be theta And then this guy is going to be half of the sine of twice theta. The antiderivative of this guy can't just be sine twice theta. It has to be half of that to undo the chain rule. And the half is here outside. And it's our job once again to put in pi and put in 0. What's convenient is when you put in pi and put in 0 here, they go away. Sine of 2 pi and sine of 0, they're both 0. You put in pi and theta here, pi and 0 here, and you just get pi. So the answer to this is pi over 2. We have 4/3, and we have pi over 2. And the last integral is the row integral. And that was rho to the 4th, so rho to the 5th over 5. So 4 to the 5th, and then we have to subtract 3 to the 5th. That's 1024. 4 to the 5th is 2 to the 10. 2 to the 10 is 1024. Computer language based off of that. And then we have 3 to the 5th, which would be 81 times 3, or 243. And then we have to all that over 5. When we subtract those, we get 781. And so there we have it. The product of these three will be the answer. And we end up with 4/3 and the pi over 2. And now the 781 over 5. And it turns out that we can take this 2 and cancel this. Make it a 2. And when we double 781, we get 1562 over 15 with the pi in there.